Fast forward a few days and here they are. My lovely board. Spidermath Multi-Charge Tester V1. So it seems to have worked out okay. I've just got one thick track on the back, all the way to positive and all the way to negative. And there's the battery connectors. The legend's printed on there, like a legend. And I suppose the big question is, will one of these fit? So let's get it the right round. They've got positives in there, although it does go positive, negative, positive. Oh, negative, 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 positive, positive, positive. That's okay. Let's get that in the right way. And hopefully this will fit in there. Oops, a little bit of bending on the terminals, but that's okay, on the little pins. But take a bit of jiggering. Actually, these have slightly bent in, so I'm going to just bend those out, but not too much, because that's what got me into the problem on all the others, breaking them. Okay, let's try again. Plus, 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 minus, minus, minus. And in it goes, apart from that one. Let's get something to encourage it. Okay, right, so that goes in fine. I'm not sure what's the best way to assemble these, whether it's better to solder the bullet connectors in first and then these after. I think it's probably the other way around, because I can put those in. These boards are the highest, but they do fit. That's the important point. They do fit in there, so excellent. And I can just solder those on without, well, I might melt it a little bit, but at least it'll keep them all in place, so that's good. So let's just check that my XT60 connectors work. Didn't think there'd be a problem with these, but they do. They go in okay. I'm going to need 2 of the female ones. Shall I? Should I put female at one end and male at the other? I'll do that, and then I've got the option, haven't I? These are all wired up in exactly the same way, but I'll do female one side, male at the other side, and do it on the top of the board. Yes, I'll do it like that, and then I can have an in and an out without really worrying about it. So let's pop that one that side, that one the other side, flip it over, and then hope that my soldering iron can generate enough heat for this. Nearly out of solder, look at that. I've had this for years, not anymore. Okay, as usual, I'm going to put the smoke extractor on this so that I don't poison myself, and I'm going to then try and solder these on. Right, this really isn't taking. I think I'm going to have to bring out the big guns soldering iron for this to do this one. I don't think my precision soldering iron is good enough for this, but anyway, I'm just going to tack this on with these, and then I'll change soldering iron and hopefully get better results. I'll just finish this one. Oh, exactly the same problem with even these. Let's go for the big iron. This should be better. Okay, they don't look melted, which is always good. Now the final battery. Okay, here goes again. Right, there you go. My first power cell tester. So I think the most important thing I can do to begin with is just check that none of these are shorting. And I've got this bit here that's quite close, these connectors. That's how the connectors are designed, so that should be all right. But I'm just going to go and check between all of these for continuity and that they're not short-circuited. So the most important, is there a connection between positive and negative? There is not. Excellent. Let's try the other end, as these are connected together. There shouldn't be. No. And now try positive to positive. Oh, sorry, that's negative to negative. Yeah, and positive to positive. Okay, so let's take that positive there. Whoops, I've got it the wrong way around. It doesn't really matter, but let's put the positive on the positive. Let's check each of these connectors. Okay, that's excellent. Now let's check the negative rail. Negative. Okay, that's safe. So now comes the big test. Obviously I'm going to use this for charging, and I'm going to use two of these together, but let's just check, put these in, and see whether I can get a voltage out of these cells to begin with. I'm only going to use these Samsung cells to begin with. I'm not going to put these other Panasonics in, because these Panasonics are a bit from quite a grotty battery pack. I got those. Let's just try these and see what voltage I'm going to get out of it. So 3, 6, 9, 12, 15, 18. So 20 volts for this should be the same. Should be okay. I know it's more than 3. I'm just seeing where we're going at the moment. So that's on 20. I should now get a voltage. Don't know what the voltage is going to be, but I'll get one. 2 volts. Okay. Which is right. Oh yes, these aren't added up. These are all in series, aren't they? What a thicky stupid. Yes. Did you know I'm making a power wall? It's going to be really good. It's not going to catch fire or anything. Right. Okay, so 2 volts across all of those all together. But it's a start. How heavy is it? That's all right. So all I've got to do now is finish the other one and start to test them when I plug these into my charger, which I think is called an IMAX B6. It's at the bottom of the box. I don't want to get it out now. But anyway, the first part of my power wall project. Woohoo! Just a little aside, really useful boxes. How really useful is this really useful box, right? When I take stuff straight out of battery packs, I can put them in here, and this box is exactly the right size for 18650s. How amazing is that? And You're supposed to test these 16 at a time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can fit 15 in each box. Isn't that amazing? But I need to do 16 at a time. Anyway, they're really useful. Beside that, really useful boxes at a store near you. Not a product placement.